Tonight's speaker, Jason Horner, is speaking. He is based in Colorado. Jason is the principal of JH Consulting, and he's focused on the Azure Data Platform, and he is very focused on data and advanced analytics. He's a longtime member of the Microsoft data community. He's a Microsoft certified master for SQL Server. He's been around a long time, speaking and providing his input and a lot of value to the Microsoft data community. And want to turn things over to Jason Horner. Welcome.
I guess the only thing I would say is I definitely encourage anybody with any questions or any kind of thing like that, feel free to email me. You can reach me on Twitter, follow me on LinkedIn. So I do a lot of small independent consulting gigs and pick up some bigger projects as well. So always happy to chat about stuff that we covered here. Using Synapse Analytics, anything kind of Azure, PowerShell, geospatial data, all those kind of things. The number one habit really in my mind is having a solid dimensional model. And this is relevant whether you're building something in Power BI and you have a Power BI data model, or you have a traditional relational data warehouse, or even if you're using like a modern kind of data lakehouse architecture. You want to have conform dimensions that you can reuse across fact tables. You want to have well-modeled fact tables. So a lot of people think that we can just jam a bunch of columns into a table and call it a fact table. That's not quite how it works. And then you want to look out for some common anti-patterns. So let's dive into that a little bit. And this is kind of an example of a lot of times what I see, especially from clients that try to move to Synapse dedicated pools. They'll try to lift and shift kind of this third normal form model here, and they won't have much success with it, right? Because there's a lot of joins, right? Which SQL Server is pretty good at handling, but there's not really a true fact and dimensional model. The flip side of that, and this you see this a lot more in the big data space, as well as in Power BI, which is where this screenshot came from, is people tend to create these one big massive tables, right? So there's no relationships, a lot of string values in here. Probably a lot of column level calculations and things like that. So you want to strive for something a little bit more balanced and in the middle, right? So some things to keep in mind. Your fact table should generally have, integer values, numeric values, potentially some dates, and maybe some strings, right? But you don't want a lot of string type values in your fact tables. Integer surrogate keys back to dimensions. The dimensions are where the bulk of your textual attributes should be. And those should tend to be pretty wide, right? So when I say wide, they should have lots of columns that really enrich the model and add a lot of business context, whereas your fact tables are generally going to be narrower. Now, that's not to say that you might have a fact table with 30 measures and 15 different timestamps, so those can get kind of wide, but generally speaking, the fact table should just be your surrogate keys, potentially a primary key, and then your numeric measures and potentially your date stamps. Now you should be using date dimension tables as well, and time if that's relevant. And now look something like this, right? So single table joins from the fact table back to conform dimensions. These dimensions would be reused across multiple fact tables. And kind of a key thing to understand is there's going to be different types of fact tables, and also fact tables and dimension tables will have what's called a grain. And it's important to understand that, if I put data in the fact table, it needs to respect, or it needs to align with the grain that's in that table, right? So if I have a table that tracks transactions in a general ledger, I can't also keep daily rollups in there. So I would need another kind of snapshot fact table to act as a summary on that. Some of the kind of anti-patterns are what I call model outliers, things that I look at. If I have more than 7 to 12 tables from a dimension standpoint, now there's larger models that will get bigger than that. Usually when I see more than 7 to 12 tables, unless it's a pretty complex business model, what I'm seeing is there's lots of lookup tables with very few attributes. So I might have a lot of mini dimension tables with maybe 2 or 3 attributes. So those are things to look at. Having tables that are fact tables that are excessively wide, right, that primarily contain transactions. And if you have loops in relationships or cascading relationships, so basically when we're not doing one-to-one joins or relationships, you'll occasionally see a many-to-many pattern where you'll have a bridge table, but generally speaking, it should be a very simple data model. It should not be super complex. So before I move on from that first habit, are there any questions around that or things that you guys have seen or other kind of thoughts around that? Okay.
Of a loop in a relationship.
Yeah, so and that's more of like a Power BI concept, but you definitely see it in a relational model too, where you basically have table A that relates back to table B, and then table B relates back, or table B relates to table C, and table C relates back to A. Does that make sense? So it's a circular relationship. Generally, usually means that something's gone wrong somewhere, and when you modeled something. It's a lot rarer to see it in a true star schema, but you see it all the time when people bring data into Power BI from a transactional model, and they're not sure what table is their actual fact table, so they'll start linking it. And there are some valid use cases where you do need to turn on like bidirectional relationships, but generally speaking, you want to avoid those because they introduce ambiguity in your model. Does that help?
That helps. Thank you.
Awesome. Cool. So habit 2 is architecture. So we'll talk about a couple things here. Mainly one
¿Ya
is
te fuiste, Samantha? Ya no prende la tele, ¿qué le hiciste?
I hope that's not a question for me. So what we have is a data warehouse architecture. You're going to typically have source systems. And the idea here is that your data is going to flow over to the right, and you're not going to have like a lot of complex relationships between your systems. So in a modern architecture, you might have some source systems. You might bring some of that data into an ODS to support near real-time reporting. You might have a data quality or a master data management system that's kind of processing data and kind of serves as a source as well. You'll have a staging layer, and we'll talk about, this is kind of showing a relational staging layer. We'll talk about data lakes as a replacement for persistent staging. And then you might have a data warehouse. It might be based on just a SQL database. It might be based on a Synapse dedicated pool. It could be based on top of, more of a lakehouse based architecture. You might build marts off of that. Those marts might live in analysis services or Power BI data models, or they could be actual individual databases. The one kind of thing where there's some complexity here is you might have an ODS that sits in front of your warehouse. I've seen that only in kind of more like telecom or customer analytic applications where we want to process a bunch of data from the warehouse, maybe do some machine learning or data science on the data, and then represent it in a database so that people can make kind of decisions. So think about like a call center support database, right? That's basing some of their operational analytics on top of data that they've ingested and processed, and they're summarizing data over a couple of years of customer behavior, looking for patterns, things like that. Fraud detection would be another place. There's certainly other technologies that could come into play here other than traditional SQL-based technologies, things like NoSQL and other data caches and stores, but we're not spending a ton of time on those. And then some kind of presentation layer. So that could be Power BI, it could be Excel, it could be ClickView, it could be Tableau. But the idea is that, like, for example, we wouldn't want the presentation layer talking back to staging or, directly to maybe the MDS system, right? And so there's a kind of logical flow here to the architecture. The other thing that's important to understand is, when we think about staging, nowadays, a lot of the stuff that I'm doing in the cloud is using data lakes to take a lot of that load of the staging. Within a data lake, you generally just break it up into multiple zones. So, for example, I might have a data lake built on Azure storage, and I might have a landing zone that's just an FTP server, and that's where people can push data to me, but I'm not giving them access into my internal zones. So it acts as a good demarc. And that's not to say you always need to have that landing zone. I've also worked with architectures where we've given different departments direct access to the raw, and they're responsible for populating that data, so that can work. The raw zone is going to be where we're going to store the data in its most basic form, not much translation. We're going to keep the raw files as they come in. And then we might, depending on what the use cases are, we might use a structured zone. So if I'm dealing with a lot of complex files, maybe I'm dealing with JSON, or maybe I'm dealing with like custom EDI file formats or other kind of textual formats that are hard to kind of query natively, I might create a structured zone where I'm sharpening data types and kind of flattening it out into a more tabular structure. I might use something like Parquet in there, or maybe CSV. Probably would lean towards Parquet. I might also use Delta Lake as well. That's kind of a new thing that's kind of coming on the horizon. Stage and temp are really just places where I'm putting temporary data sets out to. So stage would be where I'd put data that is going to be ingested into a warehouse downstream. Temp would be where I'm writing data out that I'm eventually either going to move into raw or move into another zone. So it's kind of our cache space. Ref is where I'm going to put generally data sets that don't change very much or manually maintain data sets. And then my curated zone, if I was building a data lake that's supporting user access, then I might create zones for each department, or maybe there's a zone for data scientists inside that curated zone. I could also put an actual dimensional model in there built on top of Delta Lake, or even built on top of Parquet files that people could access and run queries off of directly. The nice benefit of this is this storage just tends to be a lot cheaper than like putting it inside of a SQL database. The other advantage is I can choose what type of compute I want to put on top of it. So I could use Synapse Serverless, I could use Spark, I could use Databricks, I could use Spark pools. I could use, I could just use this as a temporary place to ingest data, or I could put Power BI directly on top of this if I wanted to, right? So it all depends on, I definitely wouldn't recommend it if I was going with something like direct query maybe. But for imported data, it could be a fine solution, and then I don't need to have necessarily a relational database in there. Any questions about that? That's usually it takes me about a full hour to go through my data lake session, so there's a lot of nuance in there, but I just kind of want to introduce the high level concepts. Okay. One other thing I guess I'll say is you guys, if you're following much of the stuff out of Databricks, they tend to favor this bronze, silver, gold. I don't like it because to me it's not meaningful from a business standpoint. So, bronze would definitely be raw, right? Silver might be my structured, and gold might be my curated if I was going to map it to those kind of concepts. Okay. As far as getting data out, I can have two paths. I can have a batch or streaming. So I could use event hubs. Kafka's a big kind of player in that space. There's a ton of other ways to get data in from a streaming data source, and then I could use blob storage to store that data. Gen 2 is generally what I would recommend these days. Storage account Gen 2. When I want to integrate or perform data transformation, these are generally speaking most of the technologies. Some of these are a little older, right? So probably not using HD Insight Spark too much, but maybe more using Azure Databricks or possibly Synapse, right? So Synapse gives us the ability to use a Spark pool as well as serverless, and then they also support the dedicated pool, which is similar to the old SQL Data Warehouse. From a streaming standpoint, you've got Stream Analytics that can work really well. Databricks supports structured streaming. There's HD Insight Storm. You can do Kafka on HD Insight, and then you can also run Spark there. And you can also, Synapse has a link capability to stream data directly into dedicated pools. And it can link to Cosmos DB as well. So some things there. As far as storing data, generally speaking, you're going to want to store the data. If you're not just strictly using a data lake for your backend storage, you'll probably pick either SQL database or a Synapse dedicated pool, or maybe a serverless pool. But you could also use Cosmos DB depending on what you're trying to do. It's a little rarer architecture to do that, but there might be some cases where, if I think about what I'm doing is I'm ingesting gaming telemetry and I want to store that aggregated for quick query responses, and I don't need to do a lot of joins, Cosmos DB is going to be a much better solution there. Other things that you see kind of in the open source stacks are things like Cassandra and other NoSQL databases, MongoDB and those. And the benefit there is the write performance is super fast and super efficient. And then you kind of have to adapt your model a little bit different to work with those technologies. And then analysis services or Power BI data models, both data sets rather, both can work to provide a semantic layer, right? And then as far as presenting the data, you've got connecting to analysis services directly, going into Excel. So, what used to be known as Power Pivot is inside of Excel now natively. You've got paginated reports, you've got Power BI service and desktop, and then you've got the search, Azure Cognitive Search if you're trying to search through like logs. It's also things that like Custo and stuff like that. And there's a few other kind of niche like time series databases and things like that we're not going to get into. But there's a whole different way of presenting and storing data. And as far as orchestration, you've got Data Factory. You can do some orchestration in Databricks. You can use functions. I've seen a lot of people try to build stuff there, or Azure Automation, or even Azure Batch. So that's how you're generally doing your data movement. SSIS would be another option there. So there's options to run SSIS either in a VM directly or in Data Factory, so you can kind of lift and shift, and there's some benefits for doing that. Airflow would be another kind of open source thing. There's not great support for Airflow on Azure. You can build your own VMs. There's some support if you want to kind of hack together your own platform as a service solution. You can containerize pieces of Airflow and use Azure Container Services, or even use web apps and some different backend technologies to kind of build your own Airflow, if that's what you want to do. Generally speaking, on Azure, I'd probably prefer Data Factory unless I'm doing lots of ETL that needs to be very low latency. So if I need to process something every 15 minutes, and I've got a lot of different data flows I've got to run, I've got to look for something that's going to be a little bit better economic model. And then to analyze data, so now it's Azure Machine Learning has kind of superseded a lot of these older technologies that were broken out. So there's a hosted machine learning environment. You can do that in Databricks. You can run your own stuff in HD Insight Spark. And then there's a whole set of cognitive services that you can kind of use out of the box to analyze your data. And so those are all kind of different how I would map that kind of logical architecture to physical architecture within the Azure framework. And we didn't get into some of the other multi-MPP type data platforms like Snowflake and things like that, but those are all certainly valid options too. So I'll pause really quick there. Any questions around that stuff?
Hey, Jason, I have a question.
Yeah,
this is Raul.
sure.
So for the analysis, if you're doing machine learning analysis, you generally want that, I guess, the raw data, right?
Yeah, that's an interesting question. So you hear that a lot, right? And if I think about, if come back. If I think about that generally means putting those data scientists against your raw data. So I think a lot of people would argue that that's what you want to do, but then I also know that, like, if I have a data scientist, I don't want them spending 80% of their time creating kind of these data sets, right? Doing an ETL that maybe we've already done. So they need to have so I'm kind of reading into where I think you're trying to take the question, but if I'm going on the wrong way, feel free to stop me. But we want to provide curated data sets that they understand, where they can spend their time doing feature engineering and model validation and model selection, right? Basically, that doesn't necessarily mean that curated zone is filtering data out for them. They certainly we would want to give them the visibility into the lineage of that data, as well as, and we'll talk more about lineage in a second here, as well as what transformations were being performed. Now, there might be some cases where, if we're working with telemetry data or kind of, data that doesn't have a lot of human touch to it, we might just turn them loose on the raw directly, right? Because there's not going to be a lot of value in curating that if it's simple data like coming in from sensors and stuff.
Sure. All right,
Yeah.
Great. Yeah, perfect. I just want to know what the best practice was. But thank you.
Yeah, and I think generally speaking, you'll say go against the raw. But if for example, if I'm trying to look at doing a sales order analysis, I want to provide those. I want to do some form of kind of transformation and flattening of that data. Like, I don't want them, if the data's, let's say I'm getting some crazy data from Dynamics as really kind of obtuse JSON files or something like that, I don't want the data scientist to have to reproject that data into a flattened data set and then bring it in. Doesn't necessarily mean I don't want to be in the business of telling him like this is a valid transaction, this is not. And when we talk about data quality, we'll talk about ways to kind of tag that data with what we think the data quality of it is to kind of get there. So it's a great question, actually.
Great, thank you.
Yep. So habit 3 is monitoring and alerting. We want to put, and this is more in the context of robust ETL kind of auditing and tracing what we're doing. And so a big concept that I like to kind of push into a lot of my solutions is to have this concept of a batch. And so anytime I start it, let's say I need to run a data warehouse run nightly. So that nightly run will get a batch ID, and then every little sub process, every data pipeline that's related to that will be tagged with that batch ID, and that data will be saved into a logging table. And then I'll be able to run reports against that to see, how many records am I processing? What's happening to the load time over time? Is it getting smaller? Is it getting bigger? If I have an error and I restart, I'll tag that batch ID so I can track the number of restarts if there was problems with those batches. And then those batch IDs become part of my operational metadata too. So another thing is, if I'm dealing with files, I might want to put some custom metadata in there. So I want to know when the file was created, right? And then when I processed the file, and I might want to calculate an MD5 hash of the file to make sure that nobody's changed it after I've processed it. I might want to tag the source. Where did the file originate from, right? So sometimes I'll do that by injecting columns into the files, and sometimes I'll do it by attaching metadata to the files themselves. Obviously, a lot of files will have Windows or POSIX timestamps on it for created and updated, but I like to maintain my own copy of that because that can't be manipulated where those file system attributes could via like a touch command or something like that. So another thing to think about is when and this would be an example of where I'm staging like some customer data, right? And you'll notice down here, I've got a create date, a modified date. I've got a hash key to identify changes there. And then I'm tagging the batch ID both for the create and for the update with that data so that I can trace the kind of the lineage of what touched it when. And if I'm doing soft deletes, I'll have an is deleted. Another thing that this is a little bit contentious, but my personal best practice is to, when I insert records into here, I always make sure the created and updated date times and batches get populated first off the bat. And then a lot of people, what they'll do instead is they'll just populate the create and they'll wait till it's actually modified to put a date value in there. But the reason I like to do it that way is then if I want to know whether a record's been modified or not, I can just check to see if the create date's not equal to the updated date. And then I'm also not having to deal with like a lot of null logic, right? And things like that. So that's my personal opinion of how to do it. And I think that makes it pretty robust. You could also use temporal tables. SQL Server has support for those. That can be a great way to kind of keep more of a ledger or a journal of all the changes that's happening to the data. But this would be kind of like what I would say is the minimal solution for this. And then if you're populating these, obviously, depending on how you're doing your ETL, the best way is to have this. I don't want to say the best way. Make sure it's getting populated, right? That could be a trigger, right? A lot of people don't like triggers because they can have side effects and stuff like that. In this case, it's probably safe, but just make sure that the ETL process is ensuring somehow that those fields are getting populated. It doesn't do me any good to have these table columns and then have no guarantee that they're being populated or that they're accurate. And then as far as I talked about the audit log, so every audit log should have, and this one's kind of geared towards ADF, so there's a lot of ADF specific stuff in here, but the concepts are the same as what you'd find in SSIS or another ETL tool as well. When did the ETL process start? When did it end? How many rows were inserted, updated, deleted, or ignored? How long did it, what was the duration? Was it successful? Is it in progress? Did it error out? If there was an error, what was the error message? So just those kind of operational metadata to tell you, to be able to trace things back and see what's happening to it. I definitely recommend not only instrumenting your ETL so that this stuff is being captured, But if you've got very complex stored procedures that are being orchestrated, track that state inside the ETL process so that it's emitting two things. One is data to the log directly, right? So every time I do a batch inside of a stored procedure, I'm going to write a log record out. And then also I might have a switch in there that'll allow me to write that data out to the standard out via like a print or a select with no wait, something like that, to basically say, hey, this is where I'm at currently in the ETL process. Because the worst thing is to have this complex stored procedure that's got 8 steps and it's been running for an hour and you have no idea where it's at, right? You have no idea to figure out where it's going. Yeah, you can go into exec requests and, kind of see some stuff, but this way is much easier. It's more approachable. You can put reports on top of it. So definitely consider that. This is another big one that I think a lot of folks don't do, is have this error event fact table. So this is a concept that came from the Kimball books. The idea is that anytime you anytime that you manipulate data within your ETL, you're checking it against a set of screens, right? So let's say I'm working with patient data and I want to make sure that the patient's age is between 0 and let's say 120. Right? So I'll create a screen that looks for data that's outside that range. If that screen gets tripped, then it's going to write a record to this error event fact table, and it'll tag the row. So the row continues to go into the model, but it gets tagged with this error event fact, and then I can summarize my data quality, right? So could probably do a whole session on the architecture of this, but the key concept here is that we're tagging data quality with these metrics, and we could have a concept where we say, okay, we have information, warning, and error, right? Error might stop the ETL cold, but we may not want to stop the ETL cold, right? So maybe error just puts the data in a suspense table rather than passing it through to the fact. And the other thing that kind of goes hand in hand with this is when I build out an ETL process, generally what I'll do is have discrete phases of that ETL. So it might be all my extracts and then all my transforms and then all my loads, right? So might extract all my data to the source, stage it, do some transformations to get it into the dimensional model, and then load it into the dimensional model. So whether you're using ELT or ETL, that's not really what I'm talking about. I'm just talking about discrete kind of phases in your ETL. At the conclusion of each phase, I'm going to write some code that validates that phase to make sure, did we get all the expected data? So if I loaded data from 5 different source files, do I have 5 different source files and do my row counts match, right? So I'm validating it each step of the way, and then I can make a decision about, do I want to continue the process or do I want to abort, right? Then that data then comes into this audit dimension. So every fact record will have an audit dimension, which will basically let me tag the records. And so in this case, I've got a couple abnormal records in here, and they're abnormal because they're out of some kind of a range, right? So it could be the fact that the quantity's out of range, or it could be the revenue's out of range. Could be a lot of different reasons. In this case, you can see the discount dollars. So the idea that we can build these really granular rules to process the data. And so this is an example of how you'd kind of roll it on your own. There's certainly open source libraries out there like DQ and Great Expectations in the Spark world. Pandas has some of this data profiling stuff. There's lots of different ways to do this, but I definitely recommend kind of creating some kind of an error kind of table to track your data quality. Questions about that before we move on? Okay. So another important thing to think about is issue tracking, and then I'm going to pivot right into this report template slide, and you're going to be like, well, what does this have to do with issue tracking? And so a lot of people hear templates and they think it's about consistent look and feel, and that is the case here. But a good template will really have the report name and the version clearly spelled out, because oftentimes when users report errors, it comes in through these reports, right? And so we also want to make sure every report has an owner. Either that could be a business unit, or it could be an author, it could be IT, right? Or maybe it's somebody out in the business that's doing it. When was the data last refreshed? And then what's not showing in this template, unfortunately, but where I'd probably cut it in is either up here in the header or down here in the footer, is a link to say report problems or questions with this report. That link then could kick off a workflow, or it could send out an email, or it could log into, if I'm using Azure DevOps or Jira or ServiceNow or any kind of ITSM tool, it could log an issue for me automatically, and then it could capture the context about the report, right? So maybe I'm looking at this report and the United States number doesn't look right to me. I could click that link and automatically generate an IT request to say, hey, this number doesn't look right. Here's what I think it should be. Can you validate that? Or this is a great report, but I want to add a feature. Well, I can click that link and automatically add a feature request, right? So that's a good thing, and that helps with our issue tracking, because that's, like I said, generally that's where people will start discovering problems with your data. This isn't a great graphic, but what it's trying to represent is that if you're a data team or data engineering, you're going to get a lot of different requests, and those requests need to be categorized and triaged and approved and go through a process, right? So it could be an operational report, right? So maybe more of a paginated report. It could be an analytical report. It could be a data extract, right? It could be a data analysis. So maybe you have a team of data scientists and somebody's requesting them to perform a model and provide kind of more of a PowerPoint deck that summarizes it. It could be a request for a new data source or a certified data model. Those things all should come into a central kind of place. It could be a SharePoint list. It could be Azure DevOps. It could be a IT service management tool. But the point is they get logged so that you can track how many requests are just coming in. And then they need to be triaged. So you need to, is the request feasible, right? Can we service this request with the data that we have today? Is it a new request, completely new? Or is it an update to an existing report or an existing data set? Are we asking to add a new column or a new calculation? Then I always ask these types of questions. Do we need to do ETL to support this request? Do we need to do data modeling? Do we need to, is there visualization involved, right? Is this thing the scope of a project, or can it be just handled as a single request, right? And then it can get approved or prioritized and then dumped into the backlog, and then obviously it's going to go through our normal development life cycle, right? And sometimes we might come in here and say, look, it's not feasible to do this because of X, Y, and Z, or there's some problem with the data set and we could cancel the request, right? But now, since everything's flowing into a single system, it's very easy to provide reports and metrics on top of that, so that you can use that as an argument to get more resources, or just to show how productive the data warehouse team is. Okay. The other thing that's really important to me, or that I think is really important to do, and this is an example of a SharePoint list. I'm a big fan of SharePoint lists just because they're easy to set up in Teams, and they're exportable and you can connect to them in Excel. But this is a RAID log, which is risk, action, issue, and decision. So a lot of times, especially when people are beginning data warehouse projects, we have all these requirement sessions and we capture all these risks, but we don't do a great job of capturing it. So this is a good way to not only capture it, but make sure that action is happening here, right? So I'm saying, okay, we need to figure out how to do delta detection. Okay, so we need to make a decision. It's assigned to somebody. It has a start date, it has a due date, and it has a status. And then every time we go through, we can put a new record in here. So 221.617, we're going to choose between change tracking and change data control. There's concerns around CDC as its preview on Azure SQL DB, right? And then maybe a couple weeks later, we go back in and we add another record saying, hey, it went GA, so we're going to go with CDC. Or change tracking is simpler, so we're going to go with change tracking. The key thing here is it allows us to get traction on these things and close them out while maintaining visibility into them, and then putting some context behind those. So this is a great tool for very lightweight, simple project management that I think in a lot of cases, especially if you're doing some agile stuff, ideally you're capturing a lot of these things as user stories or backlog tasks, but sometimes you get stuff that just doesn't quite fit into a story without a lot of kind of awkward gymnastics. This is a great way to put those things in there, and then ultimately this would probably turn into a story, right? Once it's a little bit better understood. So I think that's a great tool and something that you can implement. You could do it in Excel too, but I just think if you've got Teams, SharePoint list is great. Obviously, Slack has similar capabilities and other tools will as well. Source control, so I'm not going to spend a ton of time on that. I mean, I'm assuming that everybody's using source control for their BI projects now. It was probably a lot less common, say 8 to 10 years ago, but it should be there. If you're not doing it, you're definitely in the weeds and should work on getting everything to source control. The bigger thing I see though is a lot of times, maybe the ETL code's in source control, but the database objects aren't in source control, or maybe the reports aren't in source control, right? And so there's some challenges, especially with some of the Power BI and the reporting services artifacts, getting those in source control. But you should make sure that everything's in source control, so it can be versioned and working on, and that you have a branching structure, and if you're going to do pull requests and things like that, right? Using DevOps to make sure that you can build an environment up from scratch, right? So if I work in a development environment, I have an integration environment that's ephemeral, that I can say, okay, I've got a new code coming in. I'm going to spin up an environment, run the code through the testing in the integration environment, and it's going to pass. I'll tear it down, and then I have a gate to say, do I promote this to test, or do I just stage it and wait for some more changes, right? So again, DevOps is a whole long session, but understand those principles and concepts, and there's a lot more to it than just CI/CD, right? So anyway, that's kind of what I just described, right? CI/CD, lots of different tools to do that. There's really not a lot of excuses these days to not do those kind of things these days. Azure DevOps is kind of my default, although I'm starting to do more stuff on GitHub now that there's GitHub Actions, and that seems to be, I would still say, even today, if you're starting out a project, I would say your experience is going to be a lot better on Azure DevOps than just using GitHub, but that's going to change over time, right? So GitHub's getting a lot more of the development effort and the new features, but there's a lot of great functionality, especially around Azure boards and pipelines, and there's great integration with Teams. So a lot of people aren't aware of this, but I can actually install I guess you call it a bot. There's a bot for each of these services for boards, repos, and pipelines. It lets me do a lot of things, like I can reference a PR, or I can reference a work item, but I can also send a message to it to say, hey, what's the status of this? And if the bot's set up in Teams correctly, it can respond back, or it can auto post anytime a work item gets closed, for example. So there's a lot of cool kind of integration things that you can do with different setting up Teams channels and having these bots installed in there. Any questions around those kind of like project management and DevOps type processes? So moving on, and this one should probably be actually further up, but data quality I think is pretty huge. I see a lot of warehouses, they don't get traction or they don't get success because there's never been good validation, and that's probably because there's such a rush to get it out the door, but also because people don't take the time to really understand the data. Like, they've loaded it and they've transformed it, they think, but they don't go back and actually validate it, right? And sometimes the data is just bad, right? Like, the data needs to be corrected in the source. So data profiling is pretty big. Before you start any project, you should do a little bit of data profiling to understand what the data is. I would also do this if I'm going to do a report. Like, let's say somebody wants to do a report and they want to filter on some attribute in the data warehouse. Well, if all those values are null for that attribute, you're not going to be able to create the report. So you should do that analysis up front before you start working on the report, right? Same thing for taking on a new source system or building out a new data model. You should always do some high-level data profiling just as a sanity check. SSIS has a data profiling task. Things like Azure Data Catalog or Purview can do some data profiling. You can write SQL to do this. Pandas has a great data profiling library. There's several different Spark and libraries out there that'll do it as well. Like I said, you can do it with SQL using some constructs like this to look for null values, unique values. There's other profiling functions, so you can get pretty fancy with just with just SQL. But it can be a lot of work, and these queries sometimes don't run the fastest. So sometimes it's better to use a profiling tool. The other thing too is we kind of talked about this with the error event fact, but understanding the quality of your data, and this is an example of Talent has this data quality dashboard, but understanding your data across these different attributes, right? So how of all my data, you know, what's the quality of it? And the idea here is I could drill into these different things and actually see where my problem data is. And that's something that could be fronted by, or this could be like a front for that fact table that I showed you, that error event fact. So, you know, obviously data quality could be a whole presentation. There's 7 attributes that you need to understand. And so there's a lot written out about that. Unfortunately, there aren't great tool sets in the Microsoft ecosystem right now for doing data quality. You know, you have data quality services, which I probably wouldn't recommend for anything new or anything that's of significant size. So you're going to have to build your own, or, you know, a lot of the other vendor options tend to be a little bit more expensive. So kind of have to weigh that before you go down that path. But you got to have something in place to do some data quality assessment. Another big thing too is when you're finding bad data, don't just like write an ETL rule to work around it. If you can go back and correct that data in the source, everyone, generally speaking, is going to be happy. Now, it can be a lot of work, especially when you have a lot of audit restrictions around those source systems, and it might not even be possible, but you should always aim to see if you can get it corrected in the source, right? So a classic example of that is if you have a vendor that's sending you a file and it consistently has bad data, or the data is not in the way that you expect, see if you can work with them to correct that file format rather than trying to work around it in ETL, right? Because it might be due to a bug in their system that no one's even aware of, right? So it's worth kind of exploring that and doing a little deeper analysis to understand where that's coming from. Habit 6 is master data management. So we're going to kind of speed up a little bit because we're running a wee bit behind, but just understanding what is master data. So that's basically data that's contextual about my transactions. So here I have some transactional data like my order quantity, my amounts, my order number, my order dates, but then I have product information, I have customer information, and I have vendor information. So generally speaking, when I do master data management, it's about these 4 types of entities. It's either an asset, a party, right, like a customer or a vendor, a product or an item or a service, or a location, right? And asset and location, you can think of those as being kind of similar, but there's a little bit of difference, right? So a location could be like a physical facility, whereas an asset could be something that's located within that location. So assets generally could be moved from different places. An asset could also be a fixed asset. It could be something like a sensor, right? Like a cell phone tower, something like that, right? That could also be a location. So there is a little bit of a blurred line there. The key thing, what we're trying to do is we're trying to use our data quality to validate the data and then standardize it, match it, and then go through a survivorship process so that we don't have 3 or 4 different instances of this person inside of our data warehouse, that we know this is the one golden record, right? Reference data, that's another key thing that people don't often manage. So these could be external data sets, or they could be internal data sets, any kind of codes. Oftentimes your transactional systems will store the codes and they might have a master list of the code, but they don't really put any context to it. So when you curate these reference data sets, you can add additional business kind of context to them, things that'll support grouping and hierarchies and filtering and things like that. Generally speaking, an architecture might look like this. You've got all your transactional data. It goes into your MDM repository. You're doing data stewardship across it. You're mastering the data, and then you're publishing it back out to the data warehouse. There's certainly other master data architectures. This is a pretty basic one that's BI focused, but there's more complex architectures out there. And then always want to publish the data downstream, right? So don't maintain multiple copies of a reference data set inside the source system. Rely on publish and subscribe so that once you make changes in one place, you don't have to go make it in all these other places. Data catalog is the last one. So data catalog is really concerned with all these different attributes, right? How can I use the data? Is it accurate? Is it valid? Who can I go to for access? You have Azure Data Catalog, which is kind of an older deprecated technology, and then you have, oh, that was interesting. You have Purview, and the problem with those is that there's not a great, there's not a complete overlap of those two yet. So it's unfortunate. You either are running with Purview and you've got great lineage and data source tracking and keeping data consistent, but you lose out on a lot of the data dictionary capabilities of Azure Data Catalog. So it's not a great solution there. There's third-party data catalog products out there by Elation and other vendors that you can look at, or you could just set up a wiki. There's lots of techniques there. Key thing is, this is an example of a data dictionary, so you want to have that technical metadata, but also the real value is over here in your description information, so that people can search and discover the data and understand things about it. Also the business glossary, so having aliases and supporting tagging and annotations and classifications is critical. So I know I kind of rushed through that, but I want to make sure we're close to the time. So I'll pause for a few minutes and take some questions. The only thing that I'll try to sell you guys tonight is I'm doing a full day ADF workshop at the Microsoft Data and AI conference in Las Vegas in December. So if you want to learn more about that, it's just bit.ly.com ADF workshop 2021, or you can click this QR code and see it. If you want more resources on this talk or some of the other talks I give, you can go to my GitHub account, or you can just go to my blog and get to the same links. And then this is a link to my YouTube channel. It's kind of ugly. I need to get more content up there, but I'm working on it. But definitely would help if you could subscribe to that. So I'll pause, see if there's any questions.
So for the schema test and the data quality test, are you doing that at a certain point in time? You're building out one table and you build all the schema and data tests at that time, or you kind of aggregate everything and then down the line you start building those tests?
So I think what you're asking is like in that ETL process. Is that what you're saying, or do you just start by doing your ETL and then do you add the tests to it afterwards, like in the life cycle?
Yeah, at what stage are you doing? Are you building the tests, or putting a lot of thought into the tests?
It's tough because a lot of times there's so much pressure just to get something out. So I would generally, what I would do is I would just get like an MVP out there and just know that I need to come back and backfill those tests in there. But very quickly, like once I get that V1 in there, I'm going to start thinking about those business rules. It kind of depends on how you approach it, because a lot of people will do a little bit more analysis up front and tend to be less agile. In that case, you're going to want to define some of those data quality rules, and it kind of depends on the type of data you're working with, right? Obviously, if I'm pulling data from more structured relational sources, I need to do potentially less quality checking. Whereas if I'm getting data from CSV files, I've got to be a lot more robust about checking for data types and things like that, right? Like if the data coming in from a SQL database is an int field, I know it's going to be an integer value. Whereas if I get it from a CSV where there's no type information, I could have text values in there, I could have dates, I could have anything in there. So then those quality rules around the interface for the CSV files or those import files need to be defined up front, and then you need to put those quality rules in earlier in the process. Does that help?
Yeah, that helps. Thank you.
Okay.